I was working with at the Ford place, he went out there, the guy brought his truck in, and he says, even when I turn my key off, and I turn out and I pull the key out, the radio is still playing. And he says, and I have got to do something about this because I don't know what's going on. He said, y'all need to fix my truck. It's under warranty, whatever. So Mark, one of the guys that I trained, went out there, and he was sort of a radio nut anyway, like a lot of these young guys are. So he sure enough, he turned off the key and pulled it out, and it was still playing. And so then he got to listening. He noticed the sound changed a little bit when he turned the key off, so he folded the seat forward, and there was a boom box behind the seat. And the guy had leaned back and turned it on, and it was on the same station. And so,
wow.
just confused, And then sometimes you'll find stuff stinking, and somebody will have some lasagna that slid under the seat that's growing all kinds of mold and everything. Anyway.
That's not disgusting.
Yeah, really. All right. Okay, rain or shine, we're going into engine repair 2 test 3. And this is the day after a holiday. Sometimes we have a skeleton crew for some strange reason. I haven't figured that out yet. To check a crankshaft journal for taper, the journal should be measured in at least how many locations?
3.
Actually 2.
2.
Yeah, because what is taper? What is crankshaft taper?
It's where it starts low and curves.
Well, let's look at a journal. A journal is here. All right. The part I'm drawing here is a journal. And I'm just drawing this sort of like a crankshaft, you know what I'm saying? The taper would be if this side of the if this right here is smaller than that. So if the measurement you get here is smaller than the measurement you get there, then you got taper on a crankshaft journal. Right? Now, typically, this is just me telling you, ordinarily, you know that brand new crankshaft or that freshly machined one I got on a bench out there with the bearings and all that with it? That's what you're going to do if you're going to do it right. If you're going to build an engine and you're going to do it right, you're going to get a crankshaft kit, basically. And, we actually have, in extreme circumstances, we had a tempo in here one time that came in here knocking. And I said, well, let's just pull the pan off and see what we see. Well, we pulled the pan off and, took the rods loose from the crankshaft. And we mic'd the crank with a micrometer, with one of these, except it was one for that side. And it was perfectly within specs. I mean, there was absolutely nothing wrong with it. The bearings were hammered out. And so we we crocus clothed the journals to make them just as smooth as we could get them, clean them all up, and we put brand new bearings in there, and we plastic gauged them. You put that little waxy string in there, and you tighten it up, and you see how much it squished it out, and you know what kind of clearance you got. If you got like 1,000th clearance, which is good oil clearance, you're good. If it's too much clearance, you're actually going to have some noise, and you're probably going to be losing some oil pressure. But we plastic gauged that one, and it was within specs, and we fixed that engine knock on that tempo for $65.
Wow.
I mean, that was not even pulling the head. We just pulled the pan, put bearing, measured things, put bearings in it, put it back together, fired it up, and it ran quiet. Of course, those tempo engines are kind of bulletproof anyway, because they got a cast iron cylinder head, camshafts in the block, a real solid engine. Probably one of the last really good, solid cast iron engines that anybody made in recent history that I know about anyway. To check a crankshaft journal for out of round, the journal should be measured in how many locations? For out of round now, you're going to have to measure it in 6 locations. In other words, this thing right here that we were talking about measuring is actually round, and you want to make sure it's not egg-shaped. Typically, and let me go farther to say, if you get a crankshaft kit and you get some new bearings, and you basically have and the smart thing to do, it's going to cost you some money, is to take have the cylinder in that thing bored like 10 over at least, and get some 10 over pistons and the appropriate rings for those and all that. And you put a crankshaft kit and you bore those and you put new cam bearings in it and a new oil pump, you're probably going to be good to go. It's going to be pretty much like a new engine. Of course, having a valve job done on the heads is a no-brainer. There's a lot of stuff you can do. But most of your shops don't do a whole lot of that kind of stuff anymore because they'd rather just drop an engine in it. It's quicker, it's safer for the customer because he's got a warranty umbrella. And see, if you build an engine and some little something's wrong with it that they don't like, or it starts making a racket, then you got to go back in there and fool with it. It takes a lot of time and you lose money. So in most cases, except in warranty situations like at a Toyota place, Of course, the Toyota place, I know they were replacing a lot of engines because the PCV system wasn't working right. They were sludging up really bad back in the 00 area. But one way or another, there's a right ways to do it and wrong ways to do it. But most of these shops now will usually get a salvage yard engine or a Jasper engine or something like that and put in there because there's a warranty from the engine people. A telescopic gauge can be used to measure a cylinder bore if what other measuring device is used to measure the telescopic gauge? You're going to use a micrometer to measure your telescopic gauge. The telescopic gauge basically looks like a T, and you put it down in there, and you got to put it in there so that it's a little wider, and I can show you that when we get out there in the shop, because I think you got a sheet on it this time too. It's a little wider, a little bigger than a cylinder, and you're going to pull it up so that when it breaks over, it pushes it in and it stays there. I've also got a bore gauge, dowel bore gauge too, that I've got out there we can set up and use. All right, basically that's going to be micrometer B. Which of the following cannot be measured using a feeler gauge? That's number 4.
Valve guide.
Yeah, valve guide clearance, obviously you can't do anything with a feeler gauge to measure that. Sometimes you can typically take your valve and move it with your fingers. After you take the cylinder head apart, stick the valve in there and wiggle it around, you can tell if the valve guides need to be replaced. I'll tell you something else too. Most of your shops nowadays don't do anything except possibly valve stem seals on a cylinder head in-house. Most shops nowadays, they'll pull the cylinder head off, even for valve stem seals a lot of the time, and send it to the machine shop to have them do the, check it for cracks and blah, blah, all that kind of stuff. Not a bad idea to do that. And we send one out to Pilcher's out there. He comes back. When he sends it back, he's got that thing wrapped in plastic and all. You think it's a brand new cylinder head. What's cool about what he does, he's got a cylinder head resurfacing machine that flattens them real pretty, like if they're warped or something. But when you do a cylinder head, when he sends them out to do the valves, if you just say, well, I got his head off, I need you to check it for cracks and do the valve. So he checks it for cracks, he does the valves, and he takes a really, really light pass over it with his cylinder head resurfacing machine, and every little vestige of the gasket's gone. It looks brand new. I mean, it's just beautiful. When you get ready to put it on there, you know it's flat. He knows it's flat. You know it's flat, and it's also clean. You don't have any cleaning to do, and just you get a good machine shop does that kind of work. It's makes you want to keep using them, and his prices are really reasonable too. And used to, I tell you something else, guys. Used to there was a machine shop on just about every corner down here in this part of the country. And now there's almost no machine shops anywhere. It's hard to find any anymore. Because those machines are really expensive, and a lot of people have forgotten how to do that kind of stuff. Okay, which of the following cannot be used measuring using a straight edge and a feeler gauge? Number 5. The straightness of the cylinder bore. You can't really do that with a straight edge and a feeler gauge. Now, talking about Pilcher's again, one of the things he does, most of your shops, the ones that I was aware of back eons ago, when they would bore a cylinder, they would bolt their boring machine to the deck on the top of the block, and that's what they would use to true it up. Basically, they're just making sure that it's running straight, that it's perpendicular to the deck. Well, he don't do that. He's actually got a deal where he takes the crankshaft out and he shoots for the bore that the crank rides in. Where the mains ride. His actually uses that for the reference point. And so, if you've got that's the best way to do it, really. But if you've got the crankshaft spins here, right, and the cylinder's here, and it's actually in the block and all that junk, and the other ones would bolt something up here, and they would true it to that. He trues it to this, which is a whole lot better, really. And that other, there's a shop down there close to him that belongs to a guy that I know named Matt, and Matt does. He balances in blueprints every engine that he builds. Every engine that he builds gets balanced and blueprinted because it lasts longer. It's like not as much impact. Everything runs real smoothly. And Pilcher helps him with that too. But anyway, what measuring gauge needs to be set up and adjusted to a fixed dimension before you use it? Number 6, a dowel bore gauge. Now, what does that remind you of? What other gauge have you used in here? Some of you guys that have already been through some other courses, what have you used that you have to set to a fixed dimension before you measure something with it? Can you think of something? In other words, you've got to actually set it up before you do your measuring. What about the one you measure drums, brake drum?
I got theft it before we ever got to use it.
Huh?
The one measuring drums,
Yeah.
it got stolen.
Actually, it didn't. I thought it did, but I found it stuffed way back in a file drawer where, and I don't know, I thought I had looked there. Somebody may have heard me squawking about it and put it back when I wasn't looking. I've had that happen before too. If I start making noise about something that got pilfered, you know, I look in every drawer and it wasn't there, and then I come back the next day and suddenly it appears. You know, this is maybe one of those kind of deals. But I've got another one. I got a brand new one, you know, that I bought.
Now you can show us.
Huh? Yeah, not that hard to do. As a matter of fact, most of the guys out there in shops don't know how to use one of them things. They're totally lost whenever you hand them one. I don't know what to do with this. I guarantee you could take this tool I got and carry it over there. If you handed it, there's about an 80% chance that nobody where you're working would know how to use that. They might, but I'd be surprised because the people I've worked around, they get lost when you try to get them to measure that. But long and the short of it is, you got to set this thing up to a fixed dimension before you can measure. If you don't, you won't get a measurement. Obviously, if it's too little for the cylinder, those things ain't going to touch. And basically, it's actually measuring. When it's easier to use than doing it with a telescoping gauge, because you got a little dial here and you pull it over and you're going to find out what it is. Let me see here. Which metric unit of measure is used for volume measurement? What's that? Yeah, cc, cubic centimeters. Okay, now let me ask you this: what is where did cubic centimeters come up? What's the significance of a cubic centimeter? What is a cubic? Daniel, you probably know. What's a cubic centimeter of water weigh? Huh? What's the weight of a cubic centimeter of water? 1 gram. Think about it. Okay, so how many grams does it take to make a liter? A 1,000. 1,000, you know, you got 1,000 kilograms of water that makes a liter. So the measurement of weight, you got a kilogram is 1,000 grams, which is also a liter of water. See how that crosses, how it comes together? A liter of water weighs 1 kilogram. Now you know what a kilo is now? How many pounds is that? 2.2 pounds. You know these little dumbbells you got? You know, the little white dumbbells that got concrete in them, you know, the little cool looking, you know, it's like a 2.2 pound dumbbell, I think, or something. I don't know. But anyway, all right. Just keep that in your mind. If a paper clip weighs about 1 gram, and a cubic centimeter of water weighs about the same as a paper clip. And 1,000 grams is a kilogram, and 1,000 cubic centimeters of water is a liter. That's easy to remember, isn't it? You going to remember it if I ask you at random sometime? Well, we know second-rate amateur. Technician A says a micrometer can measure 1,000th of an inch by using a thimble that has 40 threads per inch. Technician B says a tape measure or machinist rule can be used to measure non-linear distances. Good grief. That's A. That's basically A is right on that. Yeah. Okay, this is the micrometer here. You know, basically. All right, let me ask you this: if you've got, how many turns does it take for this to go a full inch?
63.
Huh?
63.
Well, on this question it said 40. Didn't it?
A thimble that has 40 threads per inch.
Yeah. Now think. You're measuring an inch, right? You're measuring within an inch. Okay. How many divisions are there as far as turns of the thimble? These little divisions, each one of these little vertical divisions is actually 25 thousandths of an inch. You got 100 thousandths. You got 100 thousandths, 200 thousandths, 300 thousandths, 400 thousandths on this thing right here, right? Okay, so if you've got all of that, you're going to turn this thing 40 turns before it goes from 0 to an inch, right? How many 25,000 increments are there? No, I mean, how many are there in an inch?
4.
40. 25 thousandths, not 250 thousandths. See what I'm saying? So you got 40 turns on that thimble from 0 to 1,000th. See that? That's how they remember that. All right, that's pretty. If you got to start thinking the right way, or you'll be a total duhhead, and nobody wants to be one of those. Right? Okay. All right, now then, because you got measurements here, what you made the other day. You need to burn this stuff in. Okay. Now that was A basically. A Vernier Dowel caliper can be used to make all of these measurements except A, depth, B, in play, C, inside, or D, outside. Can't do nothing with no in play. All right, how am I going to measure depth with this doggone thing? That's what we're talking about. This is a Vernier caliper. Huh?
The thing on the end's for.
Like whenever you pull it open like that.
Yep. That guy
There
right
you go. That little part right there is where you measure depth. You can measure inside and outside with these little jaws here. Reading this thing's tricky if you hadn't been taught how to do it. Everybody in here confident you can read this with accuracy? You can, can't you? Can you do it, Joe?
I did it the other day.
Yeah.
I need more practice.
Yeah. All right. You do. You certainly do. Every time you get a chance, measure something. All right. Let me see. Vernier Dowel caliper is the one that most of the lazy people want to use. It's got that little dowel on it that where the needle whirls around, and it's just real easy to read. You can read it with that like here. That's like using a slide rule instead of a calculator, I guess.
The digital one.
Huh?
The digital one.
Yeah, digital one's okay. Now here's a digital dowel indicator. Believe it or not, that's a digital dowel indicator. See the little black numbers that pop up there? Now, if you're measuring something that's dynamic like the, hub lateral runout, these little black numbers moving around are useless. Give me a needle, man. See them little black numbers? Well, how you going to do that? You ain't going to be able to read that. Not if it's bouncing around like that. This was here when I came here. I did not buy this. But it belongs to the school, But I mean, like I say, it's okay if you're doing something like in play. In play can be measured with that. If you got something to set it up, you go on in there and you go donk and measure it, donk and read it, go back and forth. You're going to be able to use that and all that. Let me see. Technician A says a telescopic gauge is used with a micrometer to measure the inside of a hole or bore, such as the big end of a connecting rod or a cylinder bore. Technician B says the camshaft bearing surface and lobe can be measured using a micrometer. Which technician is correct? Both those guys are right. Technician A says a small hole gauge, also called a split ball gauge, is used with a micrometer to measure small holes such as the inside diameter of a valve guide. Technician B says a Vernier Dowel caliper is used to measure the inside diameter of a piston. Now, the interesting thing about this is it's a kind of a, if you're not really good at doing this, these kind of measurements, then you're probably going to come up with some wrong numbers. Not only do you need to know how to use that split ball gauge and that dowel bore gauge the right way, but you got to make sure that you don't distort it and move things whenever you're measuring it with the mic. That seems like a lot of candy for a nickel to me. The fewer steps you have between taking your measurement and recording your measurement, the more accurate your measurement's going to be. And they're okay. I mean, these telescopic gauges and split ball gauges, they're not bad. They're okay, but I'd rather use something else. So basically, that number 11, you got the answer to that, and there's A. Okay, what is the reading on this inch micrometer? What is the reading? This is a micrometer that's inches. Can you see it? Anybody read that for me?
Just
Which one?
12 through 19.
Yeah.
That one there is, did I skip 12 through 19? Never mind. Well, wait a minute. Did I not?
You did.
Yes, I did. But I was going to have a good time with my girlfriend. When the spindle contacts the anvil on a standard 0 to 1 English micrometer, it should read which? When the spindle contacts the anvil. That's number 12. What should it be? That's when it's like this, guys. That's when this
0, 0, 0,
is in contact
0.
with that. Huh?
C.
Yeah, nothing. It should be 0. All right. How many complete rotations must the thimble of a standard metric micrometer turn to travel through a reading of 0 to a reading of 25 millimeters? Anybody know that?
2.5.
40. You're still going 40 turns, whether you're doing inches or metric, right? Okay, when the thimble of a metric micrometer, 25 millimeters is an inch, isn't it?
Yes.
Yeah, because think about your 4-inch cigarettes. Isn't that a 100 millimeter cigarette? 100 millimeter cigarette is 4 inches long, right? All right. Look at that. He's going to dig a cigarette out and take a measure and measure it. Go
So the
figure.
ones that say 100 on them are orange ones?
Yeah, the ones that are hundreds are like a 100 millimeter cigarette. You know, not that I'm a great proponent of cigarettes, but that's just the way you can remember it. Okay, let's see. A telescoping gauge is usually used to measure what?
You skipped 14.
Oh, excuse me. Yeah, no. Well, let's see. Oh, yeah, I'm sorry. When it's turned one full revolution, the dimension between the anvil and the spindle has been changed by what? 0.5, 2.5, 0.1, or 5.0. Now, you've turned it one full revolution. How far has it moved when you turn it one full revolution?
40.
Try 0.5, okay? 0.5. A telescoping gauge is ordinarily used to measure, what is that? It's going to be C, isn't it?
Yes.
Outside diameters larger than 5/16 of an inch.
That's inside diameter is larger than
Outside?
5/16.
Yeah, isn't that crazy? That's a screwed up thing there.
The answer's wrong?
Yeah. No, actually, it's supposed to be C. I'm sorry.
Well, that's the one you said.
Yeah, I looked at
You read it wrong.
I looked at the answer key wrong. I looked at the test wrong after looking at the answer key. Technician A says the two types of dial indicator faces are balanced and read continuous readout. And technician B says a balanced dial indicator face will have a plus or minus reading. And who's right about that before? You only like that, don't you? Both of those guys are right.
Oh,
You want it to have plus and minus readings, you know. If balanced meaning what? What do you mean when it say it's balanced?
even.
No, you've actually, oh, come on, Joe. That means you've turned it, whenever you set it up so that you got a nice even reading, right? Where your needle can sweep both ways and is actually measuring something sweep both ways. You're going to dial it around so that when it's right in the middle, when you're at your neutral measurement, if the zero is going to be there and you can see how far back and forth it's sweeping. That's the way that I read that. So, okay, so what should you use to check a outside micrometer for calibration?
Micrometer.
They've got a bunch of little things that come with it that are standards. That's what you call those standards. And whenever you'll have you'll have one that's an inch long, one that's 2 inches long. Why don't you need a standard for this little sucker here? You got standards for all the rest of them. Why don't you need a standard for this?
Because you have a standard when it hits flush.
Yeah, when it's all the way closed up, it's already at its standard, 0. But you got to know where 0 is on the 1 to 2, the 2 to 3, the 3 to 4, and the 4 to 5, and the 5 to 6. And they're all reading in a 1 inch range. What tool is best used to measure valve lift?
Ruler.
Huh? What about a dial indicator?
Dial.
What about one of these? A little dial indicator. This one right here doesn't really have a dial on it, but it's like that. Okay, now let's go back to the one that I held up a while ago. Anybody can read that mic for me? Read the mic. Read the mic. What is it? Got any idea? Number 19. Got something going on there.
B.
Huh?
B.
All right, now what can you see? Can you see the first line?
Nope.
You cannot see the first line. Okay, so what do you think?
2, 0. 1.
Which one of those answers is it? What'd you say, Daniel? Is it 0.210? Is that right?
Well, we're gonna look at this other thing.
Is it 0.212?
Have you? I believe you skipped a number in those
Missed
first
the
two,
0 in that second one.
and the first one too. Oh,
We'll cover that in a minute. 0.210? We're at 0.260. Oh, 0260.
Okay, oh, 2, 1, 2.
What do you think?
212.
Where do you get the last two?
These little numbers down here below. They're all fine.
How many of those little ones are there? He's on target.
There's another 10 of them, but the 2 lines up.
Yeah, he's got a pretty good idea. He's actually taking it to that last decimal point. Now, if I was taking this test, if this was an ASE test and I was taking it, I would put 0.210. Now, I will tell you this, the ASE people are not going to throw you a curve and try to trick you. I mean, they just won't. If you figure out how they think and what they want, you can actually do pretty well on that test if you know your stuff. But you got to figure out how they think and what they want. That's basically how the ASE test works. Are you slated to take one of those, or are you getting ready to take one? Yeah. Yeah, you're going. So, but you're planning on taking one. Okay, let's do another one. What's the reading on that one? B is supposed to be the right one on that one right there.
528 L.
Huh?
528 L.
All right, we got. I would say that you're probably pretty right. So I can see the first line after the 5, that's 25, and then I'm going to add 3 to that, and that's, well, yeah, that's right, because that's a little over ½ an inch, isn't it? That's pretty strong. Of course, Daniel, I tell you what he was looking down there on the bottom was that little deal there. They're wanting you to be able to see the back sides, what they want you to be able to see. So you see the back side, you understand how that back side works? All right, now let's look at number 21. What's the reading on this metric one? Ooh, that's a tricky one. What do you think?
187.
You got that? Number 21? 187? 0.187. 0.187 millimeter. What does that mean?
187.
Of what? I mean, what portion of a millimeter is that?
100,000.
I mean, how do we break up millimeters? What are they broke up in? What is a millimeter broken up in? Hundredths of a millimeter, right? If you got hundredths of a millimeter, 0.187, how do you figure that? That's spooky, isn't it? You haven't even reached 1 millimeter yet, have you?
Nope.
That's less than 1/5 of a millimeter. Isn't it? I mean, they're basically want to take it.
Tiny.
It's 1/1800ths of a millimeter is what it is. But you're basically carrying it out to another decimal. That's what you're doing. All right, now let's go to this one here. This is another metric micrometer. That's number 22. What are we getting there? You got to get good at this. What are you coming up with? Number 22. I can see the 5. Can you see the 5? Okay, so that's 5 millimeters, and then it's part of another millimeter, but we need to know what part of another millimeter it is. But it's simple to read, isn't it? What do you think? Somebody guess at it.
535.
Yeah, 5.535. See how simple and quick and easy that is?
You know, I'm noticing something, Rich.
Huh? Are you getting smacked around over there?
No, I'm noticing something. All the answers from 20 to 22 were B.
B.
Very good. All right, 23. Let's look at this Vernier Dowel. Now, you notice it says each one of these divisions is 2/1000 of an inch. You got that?
Okay, so
All right, so which one is it? Each small line is equal to 2/1000 of an inch.
8, 6.
Okay, so what kind of reading are you getting there? You got to look at that scale now on the side there too.
D.
I can see my 5, right? And I can see 1, 2, 3, 4. And that's 5.5 something, but what is it? All right, if you've got each one of those is 2/1000 of an inch. You got me? So you got 3 marks. You're 3 marks past your 80,000ths, right? So 3 times 2 is what?
6.
Okay. What do you think about that? Can you parse that and tell? It's more than 5, okay. We're looking at 5.